Okay, so we're going to be talking about the distance formula and the midpoint formula. And specifically, we're looking at kind of where it comes from so we can kind of connect the idea, what does that actually mean? And then maybe look at an example or two of what that looks like, okay? Then we'll do the rest of these together in class. Well, the distance formula, what we're referring to is the distance between any 2 points, okay? On a coordinate plane, can we find the distance between any 2 points, okay? And actually, that ties directly into the Pythagorean theorem that you guys have seen before, a squared plus b squared equals c squared, the sides of the triangle, okay? So that Pythagorean theorem. We know that a squared plus b squared gives us the hypotenuse c squared, okay? But notice the hypotenuse shows us the distance between these 2 points, okay? And we're going to apply that same thinking in terms of finding the distance between any 2 points, okay? Now, the way we want to think of it is if we let one of those guys represent the run and the rise, then we can find the distance between those 2 points, okay? So if we can think of A as the run and B as the rise, then we can find the distance between any 2 points, which would be on the hypotenuse C, okay? The distance between those 2 points. Now, the thing about the rise and the run, I'm going to kind of go over here now, is when we think about it on a coordinate plane, the run is represented by X and the rise is represented by Y. So really, what we need to know is the distance between these 2 points first to represent our A value, and then the distance between these 2 points, we use a different color here. Oh, that's already red. Let's try blue. There we go. A different color here. These 2 points to represent the Y value here, that B. Okay. Now, how do you find the distance between how do you find the distance between any 2 values, okay? We subtract them. Right? So in this case, if I know that this is x1, this is x1, y1, and then this guy over here is x2, y2, then I need to find this distance to run, right? Well, what do? Well, I take x2 minus x1, and that gives me the run. If I subtract my x values, the x of this point and the x of this point, that gives me this distance a, okay? That gives me the run. Well, then how do I find the distance of the rise? Well, that's subtracting the y values. If I take this y value minus this y value, in other words, y2 minus y1, that gives me the rise b. So that would give me the distance a and the distance b, the rise and the run, okay? Then if I know those values, if I know that the run is just x2 minus x1, and I know that the rise is just the y2 value minus the y1 value, I can substitute those values in for my run and my rise. Well, now I have something to work with here. I know that my distance, kind of going off of what we played off here, we know that the run is x2 minus x1, and then the rise is y2 minus y1. Substituting those values in, now I know that x2 minus x1 squared, which was our a value, plus y2 minus y1 squared, which is our b value, is equal to my distance squared, which is the c value. Okay? So we said earlier that A was this guy, B was this guy, and what we're looking for is the distance C. Okay, so just to kind of tie this all back together. Well, what do we know about the Pythagorean theorem? A squared plus B squared equals C squared. So these guys squared added together give us the distance squared. Okay, so that's where this comes from. Okay, now I don't want to find the distance squared. What I want to find is just the distance. Well, what I really need to do is take the square root of this guy so that this cancels out, okay? So the square root and squaring something are opposites. However, go back to when we're solving an equation. If I do something to one side, I also have to do it to the other side. So if I take the square root of that guy to just get distance, then I also have to take the square root of this side. Okay, so that's what leads us to this guy, is they take the square root of both sides, and now I have distance by itself. Well, what we just discovered here, or kind of put together, is the distance formula. Okay, so now we can plug in any 2 points into this formula, and that will tell us the distance between them. Okay. For instance, if I know that I have A and B on the coordinate plane, and A is 1, -2, and B is 5, 1, we can label the first one x1, y1, say it's my first x value, my first y value, then x2, y2, okay, the second x value and the second y value, and then plug those into the formula. Well, this is the formula here, and that's going to give us our distance d, okay? So that's what we're trying to find here. So what I'm going to do is where I see x2, I'm going to put 5. Where I see x1, I'm going to put 1. Where I see y2, I'm going to put 1. And where I see y1, I'm going to put -2. So plugging those in, we have 5 minus 1. So I'm subtracting my x's, 5 minus 1, squared plus 1, my y2 value, minus, now here's the key there, it's minus a negative, okay? So don't make the mistake. It's minus a -2, because that's what y1 was, squared. Well, then it just becomes simplifying. What's 5 minus 1? 4. Now, what happens when you subtract a negative? It becomes addition, right? So 1 plus 2 is 3. Now we're down to this guy. What's 4 squared? 16, so I'm actually going to write this above there so you can kind of see it. 16. What's 3 squared? 9. 16 plus 9 is 25, okay? Square root of 25 is 5. So these guys are a distance of 5 units away from each other, okay? So that's the distance formula, and it plays off the Pythagorean theorem where x2 minus x1 gave me my A, y2 minus 1 gave me my B, and we know that if I square A and I square B, add those together, I get the distance squared of the hypotenuse, okay? Then the midpoint formula, it also plays off of something that you're familiar with. How do you find the average of any two numbers? An average representing essentially the middle. You add them together and divide by 2. That's essentially what's happening here with the midpoint formula. It takes our two x value coordinates, adds them together. So look at this guy here. It adds the two x values together and divides by 2. So it's finding the average or the middle between those two x's. Same thing with the y. It adds the two y values together and divides it by 2 to find the middle of the two y's. That's the midpoint formula. We're just finding the middle x value, the middle y value, and that becomes our new coordinate. Okay, so it's not actually a number, it's a coordinate. Okay, so the midpoint formula gives us a coordinate here. So using that and putting that into action here, let's say I had this guy. Let's say A is 1, 4, and B is 6, -5. Well, let's call it A, x1 for the first x value, y1 for the first y value, x2, y2 for the second x value and the second y value. Well, then I just plug it into my formula, which is this guy here. Okay, so x1, I'm going to put a 1, x2, I'm going to put a 6, and then y1, I'm going to put a 4, and y2, I put a -5. So that's what they have here. We have 1 plus 6, 4 plus a -5. Then it just becomes simplification. What's 1 plus 1 plus 6, jump into the answer there. 7, right? And then 4 plus a -5, well, different signs subtract. 5 minus 4 is 1, and then we keep the sign of the larger, which is 5, so it's -1, right? So then I have 7 over 2. Well, 7 divided by 2 is 3.5. And then a -1 divided by 2 is -0.5. So the point directly in between, the midpoint directly between these two is 3.5, -0.5. So if we plotted if we plotted A, B, and this guy, my new midpoint here, on a coordinate plane, this guy would be the midpoint right between those two, okay?